reasoning. Inductive reasoning comes from reasoning that is based on the patterns you observe. Dominic.
In other words, it's an educated guess.
Using, not educated, it's educated because you're using patterns or observations. Okay, so we're looking at patterns. So if you look at the first example, we have a bunch of different types of patterns. So we need to identify what the pattern is so that we can come up with the next number or the next figure in the pattern. Now in part B, there is some shading involved. The shading was very poor. Our toners are not very good right now in our printers. So if we look at the first one, the number pattern, okay, you guys did this last year in algebra. You probably looked at different types of sequences and wrote up the formulas and the equations for the sequences. But let's see if we can figure out the pattern without that. 3, 6, 12, 24. What's happening? Everything is being multiplied by 2. That's the pattern.
Is that how multiplied is spelled?
Yes. So what would be the next two terms in the sequence? Bryce, or Broom. Yeah. 48 and then 96. Good. Okay, so given a series of numbers, can you identify the pattern and come up with the next numbers in the patterns? Given a geometric figure, I guess there isn't any shading. Is there shading in there? I guess not. Maybe I didn't put shading in. Given any geometric figure pattern, here we had 2 halves, here we had 4, here we had 6. So what's going to be the next figure? 8. So see if you can get your 8 dissections. Hello? Yes. Sure. All right, so just get caught up with this. You can look in the textbook. You are dismissed for your appointment. What will be the next circle? How many slices? 10. How do we get 10? 1, 2, 3, 4. That gives me 8. That was not very even. That would get me 10, right? Or am I at 6? 1, 2, 3, 4, 5. That's 10.
So we just divide it by 2 every time?
Yep. Okay. So we're looking for patterns. Questions about finding patterns? All right. So after we found that pattern, we are going to make a conjecture. So the conjecture is your conclusion. So you guys made conjectures about me as a teacher by looking around the room. So a conjecture is a conclusion that is reached using inductive reasoning. So we make conjectures when we're dealing with inductive reasoning. So it's just your statement to come up with your conclusion. So we looked at the previous patterns. What was the pattern? Well, the pattern was each number was being multiplied by 2. That would be a conjecture. That's my conclusion. Then what would be the next two numbers? 48, 96. All right, so let's make a conjecture about the sum of the first 30 odd numbers. What are odd numbers? 1, 3, 5. Okay, so let's look for a pattern, because I could sit here and I could do 1 plus 5 plus 7 plus 9 plus 11 and do it for 30 of those. Okay, that might take a while, but let's look for a pattern. Let's do the first 2. 1 plus 3 is what?
4.
Let's do the first 3. 1 plus 3 plus 5.
I have a question.
9.
Dominic, quiet. 1 plus 3 plus 5 plus 7 is 16. 1 plus 3 plus 5 plus 7 plus 9. 25. All right, so that only got me up to the first 5. Well, it wants the first 30. Do we see a pattern forming? What's the pattern? They all are perfect squares. That's a good pattern, right? Okay, here I had 2, first 2, and what's 2 squared? Here I had the first 3, it's 3 squared. 9, what's the first 4? 16, what's the first 5? 25. So there's a pattern. Do we see another pattern with the sums? They're rotating between what? Odds and evens. So when I have an even number here, I'm going to get an even sum. If I have an odd number, I'm going to get an odd sum. So 30, Yeah, 30 is an even amount of numbers, so that means my sum's probably going to be even. And 30 squared is 900. So our conjecture would be that the sum of the first, Dominic, please don't shout out. The sum of the first 30 odd numbers is 30 squared, which is 900. Dominic, do you mind getting up so Jimmy can scoop behind you?
No, I come on.
You're okay? Okay. So that would be our conjecture. We just made a statement about looking at a pattern. We looked at a pattern to figure out what it would be for the first 30. Okay? All right, flip on to the back. So we've talked about patterns. When we find a pattern, we make a conjecture. And sometimes when we look at something, we might want to try to find a counterexample. So a counterexample is exactly what it sounds like, an example that counters something. So if we make a conjecture, it may not always be true. If I want to prove that a conjecture is incorrect or that a conjecture is false, I need to find a counterexample. So a counterexample is an example that shows that a conjecture is incorrect. And you only need one counterexample to disprove a conjecture. You don't need to find multiple counterexamples. If you can find just one counterexample that makes something false, then you have a counterexample to say it's false. Dominic, what's your question?
I'm just going to say, this is starting to sound a lot like a court case.
Yeah, kind of, right? All right, so here is a conjecture. The square of any number is greater than the original number. Can we come up with a counterexample for it? The square of any number. So someone give me a number. 1. Let's think about 1. If I take 1 and I square it, I get what? 1. Is 1 greater than the original number?
1 is greater than 1.
1 is not greater than 1. 1 is equal to 1. That would be a counterexample. Can someone come up with a different counterexample?
-1.
If I take -1 and I square it, I get 1. That's going to still get me to the same thing.
0.
Ashley? 0. Well, 0 squared would be 0. So 0 is not greater than 0. What about fractions? If I squared 1/2, what do I get? Yeah, I get 1/4. Is 1/4 larger than the original? No. Okay, so as long as I'm picking a number that is 1 or 0, or a number in between 0 and 1, then we're good to go. So those would be examples of counterexample. For a counterexample, you just need one example. Part B. You can connect any 3 points to form a triangle. What would be a good counterexample? What would that look like?
3 points on the same line.
3 points on the same line. Very good. So if I have 3 points that are collinear, do those 3 points make a triangle? No. This statement is saying that any 3 points do form a triangle. Well, that's untrue. Right here I just made 3 points that don't make a triangle. So that would be a counterexample. For C, any number and its absolute value are opposites. What would be an example, a counterexample? If I took the absolute value of 4, I get 4. Is that number opposite in sign than that number? No. So that would be a counterexample. Okay? So we use inductive reasoning to look at patterns and observations to make a conjecture. And sometimes we use counterexamples to make a conjecture to show that it is not true, that it is false.